The second session of today's meeting will address the ethical issues and responsible conduct of research in gene drives, with a focus both on professional self-regulation and questions of societal ethics, ethics in science. And we're going to start, we have 4 presentations, one of which is a team presentation. But we're going to start this morning with Dr. Frank Macrina from Virginia Commonwealth University, who is both a microbiologist and has been active for over 2 decades in the field of responsible conduct of research and ethics in science. And his presentation is on scientific integrity in research on emerging technologies. Dr. Macrina.
Thank you, Liz. Thanks to the committee for the invitation to be here today to talk with you about gene drives, genome editing, and responsible conduct of research. I would begin with a presentation of the definition of responsible conduct of research as articulated by the National Institutes of Health and as has been also mentioned in professional societies and other venues, is that responsible conduct of research, affectionately referred to by the RCR acronym, is defined as the practice of scientific investigation with integrity. Involves the awareness and application of established professional norms and ethical principles in the performance of all activities related to scientific research. When we think about integrity, we think about honesty, openness, trustworthiness, principled behavior. The bolded font in that definition is mine: established professional norms and ethical principles. Where did they come from? There was a time when I think a lot of what drove scientific behavior could be described as folklore, and the quick answer to the question of how did we learn that? Well, it happened in some form of mentoring. I would like to submit or argue that, in fact, we have a growing infrastructure of norms, best practices, and ethical principles that are embraced in the kinds of things that have happened in examples we've heard about today, the recombinant DNA example, and I'll use that in a moment. But to give you an idea of specific written norms, codes, and policies, I decided to list the topic areas that the NIH cites as being commonly presented in responsible conduct of research courses. And at the top of the list are subjects protection and laboratory safety. It hasn't been that long since, in fact, there were laws passed to govern the use of human and animal subjects in research, really less than 50 years. The same is true for radiation safety and chemical safety as well. So we want to know how to behave and what we ought to do. We consult those policies, and that's how we embrace responsible conduct of research. Lumping together authorship and publication with peer review. 20 years ago, 25 years ago, instructions to authors, publishers, guidelines, and even societal positions on authorship were brief at most. Said very little, were more concerned with technicalities of publication than with responsibilities and duties of authorship. You can check your favorite journal. My experience is that instructions to authors in general have grown tenfold in terms of size, and scope has increased dramatically. Again, when we want to adjudicate authorship disputes, when we want to determine whether someone has been inappropriately listed on an author's byline, there are documents we go to, including some standards like that proposed in 1978 and now updated many times by the International Committee of Medical Journal Editors. Again, written documents, codes, and policies that help us articulate what we ought to do and allow us to promote the responsible conduct of research. Conflict of interest, wasn't until 1995 that federal agencies began talking about what NIH termed as objectivity in research. And as probably most in the room are aware, the disclosure of conflict of interest has become a very important topic with federal funders, with research institutes and research universities. And again, we've got standards and documents to look at. I'll stop with the dimensions of data. Visit the NIH data sharing webpage, or look at the covenants that have been published by the AAMC, or the requirements of NSF and NIH regarding plans for mentoring trainees, be they predoctoral or postdoctoral. My point to all of this is there are written standards that guide how we should behave as scientists, and we're here today to talk about an emerging technology, and one which I think has been made clear in the first series of talks is headed towards policy making, regulations, best practices, using the open discourse that actually has been begun by this committee under the leadership of the National Academy of Sciences. Let me use 4 examples of situations that I think will drive home what we're doing here today, not necessarily to extrapolate this is how we should be doing things, but I think these examples give us some insight into process. The discovery of recombinant, I'm not going to use that, recombinant DNA was sudden, was brought to the attention of the public by scientists. The ability to splice genes together raised serious concerns on the part of scientists and the public. There were papers published, there were letters written. Ultimately, the National Academy under then President Philip Handler took the lead, charged Paul Berg with setting up a meeting to discuss this. We've already heard about the Asilomar meeting. I'll talk about that in my concluding slide. There was a voluntary moratorium on the performance of certain kinds of recombinant DNA experiments. Ultimately came down to NSF making recommendations, and then the federal government took the ball from there. I use the responsible conduct of research movement, if you will, including the development of policies that deal with the identification, prosecution of misconduct allegations, as well as the requirement for education in responsible conduct of research. The event being that there were a number of high-profile cases that made it into the media, were clearly talked about and made aware of by the scientific community. These prompted congressional hearings. Then Congressman Al Gore conducted hearings back in the early 80s based on what had been a spate of high-profile cases. And then in the late 80s, John Dingell chaired a committee on fraud, research grant fraud, that spoke to some high-profile cases as well. I'm talking about events and the initial engagement. In the next slide, I'll talk about the actual outcome or the oversight, if you will, that came from this. The biosecurity topic really came into sharp focus with the anthrax attack of 2001, but there were also some controversial papers along the way, including the genetic engineering of mousepox virus that was initially aimed to be part of experiments on a contraceptive vaccine for mice, which were a agricultural pest in Australia, but in fact showed that you could increase the virulence of a virus somewhat related to smallpox by genetic engineering. This led to a state statement on the part of journal editors that was published in Nature and other journals that talked about monitoring what was intended to be published in the literature with respect to the potential evil use of scientific discovery. That gave way to a National Academy committee that published a book on biotechnology research in the age of bioterrorism. The committee was chaired by Jerry Fink, and the report is known affectionately as the Fink Report. This has evolved. This began in the early 2000s. One of the things that this report called for was a national committee that I'll talk about in a moment. And right now, our concerns are focused on the genetic engineering of influenza virus, such that there is a gain of function in virulence, or so-called GOF studies, that are concerned in the sense that although they may illuminate our understanding of infectious agents, these genetically engineered agents may give rise to agents of bioterror. Genome editing is the general term I use for what we're here to talk about today. Genome editing makes possible the gene drive technology that we've talked about. So the discovery, understanding, and application of the CRISPR-Cas9 technology was the event that focused that particular conversation. Where we are right now is we're in real time. We've seen papers published that are calling for careful looks at the development of regulations and policies. We've seen this as a theme throughout some of the earlier talks. Now let's look at what's happened by way of the oversight mechanisms. Recombinant DNA is the most mature example, one in which there were National Academy recommendations. This led to an NIH advisory committee, recombinant DNA. That morphed into the Recombinant Advisory Committee, the RAC, which in a real sense still exists today. There were guidelines published. The FDA got into the act when it was clear that recombinant molecules could be used in a clinical setting, in gene therapy, for example. The institutional biosafety committees were brought into play, as were the institutional review boards. Ultimately, there were guidelines published. The first iteration on recombinant DNA guidelines appeared in 1976. They were most recently updated in 2013, entitled Research Guidelines for Research Involving Recombinant or Synthetic Nucleic Acid Molecules. Again, written documents, policies, guidelines that deal with how we address this research, what we ought to do, in some cases what we should not do, or what we need to do to get approval in order to do certain experiments. The responsible conduct of research conversation led to federal oversight agencies, the formation of the Office of Research Integrity. There were policies that dealt with accepting federal funds, and the fact that you needed a policy to do so in the case of NIH or Health and Human Services that would identify how you are going to identify misconduct, investigate it, and prosecute allegations of scientific misconduct. There was mandatory education that continues to grow from federal agencies, that trainees receive education in the tenets of responsible conduct of research, and there's been an institutional infrastructure formed, courses, formal courses. The fact that every institution that accepts funds from Health and Human Services agencies has to have a research integrity officer to run point on the implementation of the process. In the biosecurity era, the Fink report articulated experiments of potential concern, dual use research of concern, if you will. They called for an enhanced manuscript review. Most recently, the 2005 marked the formation of the National Science Advisory Board for Biosecurity. This was the national committee that the Fink report envisioned. This committee has done a lot of work in creating documents. You can visit their website to examine them yourselves. Most recently concerned with the topic I mentioned earlier, gain-of-function study specifically in influenza A and a couple of other groups of viruses, again, driven for the good causes of better understanding infections, but running the risk of creating genetically engineered viruses that could be used for evil purposes. They recommended to the U.S. government an oversight policy that went into effect last month that universities now have in place that includes an institutional review entity that works in a process that I'll describe momentarily. Genome editing, again, I mentioned papers being published by international experts, multiple international experts writing about what we need to be thinking about, basically opening the discourse in full transparency in what we may want to be thinking about as we look to what should govern gene-drive research. And we've certainly heard examples of where those concerns might be raised in the earlier talks. Let me use an example from the NSAB, from the National Science Advisory Board on Biosecurity, that deals with the whole publication issue and what that committee has been working on and how the process has worked in journals that are published by the American Society for Microbiology, was written about by Arturo Casadevall, a former member of the NSAB and colleagues, in August of this year. And if you look at this process starting in the left corner, author discloses is equivalent to the paper being submitted. The editorial staff, and ASM publishes, I think, 11 or 12 different journals in microbiology, infectious diseases, and related disciplines. The manuscripts are screened and flagged if they may involve dual-use research of concern. Reviewers are asked to specifically concur and explore this in their review, and ultimately recommendations are made to the editor, who consults with the editor-in-chief. So that's the screening process. The discussion starts with the editor-in-chief, flows down to the ASM Responsible Publication Committee, and may even involve outside advice, with the decision being rendered such that the paper is published. It could be redacted and then published with an editorial, or perhaps even rejected. The point of the paper by Casadevall and co-authors is that at the time the paper is submitted, we have completely missed the boat in terms of a discussion of the implementation of the experiments to begin with. The experiments are done, and this process won't do us a service other than to go through the motions of reviewing the paper, when in fact, as the authors argue, we should be less concerned about a filtering mechanism and more concerned about pre-study of the actual experiments. And in fact, that is the way the recombinant DNA advisory infrastructure worked in the beginning and continues to work, that experiments that need scrutiny are basically scrutinized before they're even done, much less written up for publication. Now, if we turn our attention to the policy that I mentioned, which can be accessed at that link, this is the policy that the U.S. government put in place. Basically, it was the work product of the NSAB, and it begins with a process that is not unlike the evaluation of recombinant DNA experiments. That in fact there is an evaluation, self-disclosure by the investigator before the experiments are ever done. So in part, it's based on a very confined kind of a parameter, and that these are experiments that are being done with the so-called select agent list of pathogens and toxins. So it's highly focused at this point, but it obviously has the latitude to expand. But there are a whole series of steps that ultimately deal with the genesis of a mitigation plan. So before experiments are done, there has to be approval that is largely focused on an institutional committee called the Institutional Review Entity, or the IRE. This speaks to the lessons we learned with the recombinant DNA experiment, and refocuses, as Casadevall and his co-authors pointed out, on pre-study contemplation of the implication of the experiments. And these are obviously huge issues given the science that we're talking about today. So by way of take-home points, I think there is something to be said for looking at the historical precedent of the whole recombinant DNA experience, and the current activities of the whole dual-use research arena, including the NSAB and the policies it's working on. Someone mentioned that asilomar wouldn't be a good way to do it. Paul Berg has written that he agrees with that things are more complicated than they were years ago, and in fact, open discourse should really drive this, and it's distributed discourse, starting with the kinds of activities we're doing today. Expert leaders should be relied upon in the contemplation, in the drafting of policies. Responsibility should be shared across the board, starting with investigators straight through publishers. Those of us in RCR education need to incorporate these kinds of things as we talk about the implications of the scientist's role in society. And that lastly, that openness and transparency in policy development and implementation are really needed to ensure the public trust. Thank you.